So in this video, we are going to see problem from exercise 9.3, which belongs to chapter number 9, areas of parallelograms and triangles. Okay. So let's come down here. This is the figure that we have to refer. So we're going to look at problem number 2. In the previous video, we saw problem number 1. Problem number 2 is related to problem number 1. Let's read what the problem number 2 says. In a triangle ABC, so this is our triangle ABC, E is the midpoint of median AD. So this E is the midpoint of this median AD. Okay, so I'm going to highlight it. First of all, AD is a median, that's an important information, and E is a midpoint of this median, which immediately means that AE is equal to ED, okay, because E is the midpoint. At the same time, since AD is the median, so we can immediately conclude that BD is equal to DC, because that is the definition of median, that a median is a line which connects a vertex to the midpoint of opposite side. So D is the midpoint of BC. So I'm also going to make a note of that BD, okay, is equal to DC. I'm just going to represent 3 lines. Now, E is the midpoint of median AD. Okay, show that area of BED. So this is our triangle BED. Area of BED is equal to 1/4 the area of whole triangle ABC. So ABC. So BED should be 1/4 of ABC. Okay. Now, why is it related to the previous question? Because in the previous question, E was any point on median AD. It was not a midpoint, it was a random point on a median, and we have proved that ABE is equal to ACE. So ABE is equal to ACE. That is what we proved in the previous problem. Similarly, we proved that BED is equal to EDC. Okay, in the previous video itself. So that conclusions we already have. So I'm just going to come here now, zoom in. Okay, so I'm just going to write here from question number 1. So that's the previous question. Question number 1, we have. So we have triangle. So I'm going to write here area. Area of triangle ABE, okay, is equal to area of triangle AEC. So I'm just going to highlight it for the sake of understanding. Okay, and just remove this. Okay, so so ABE, this triangle area, is equal to this triangle AEC. That was the first thing, and area of triangle BED. So once again, let me use a highlighter. So this is our this is our BED. So this triangle's area is equal to DEC, this triangle's area. That is what we have already proved in the previous question. So you might have to revisit the video and see this concept again. So BED is equal to DEC. Okay, this thing is already proven. Now in the previous question number 1, E was any random point. Now the additional information we have is E is a midpoint, and we have to prove that this BED is 1/4 the area of the whole triangle. Now that is possible if areas of all 4 triangles are equal to each other. Then we can easily say that BED will be 1/4 of the whole ABC. How do we prove it is something like this. So first of all, let's get rid of this. Okay. And I'm also going to get rid of this because we don't need it at this in this discussion. This thing. Okay. Now the key information that we were given is that E is the midpoint of this triangle, of this line AD, of this median AD. So now I have to prove that this triangle is equal to this triangle in terms of area. So once again, let's highlight it. So ABE, okay, should be equal to BED. Now, if two triangles have equal bases, so this is the base AE and this is the base ED for this triangle, and if they lie between two same parallel lines, so this is my parallel line AD, I need to construct another parallel line which will pass through this point B. So that is what I am going to do right now. Let us draw a line which passes through point B and is parallel to AD. Okay, and I'm going to just move it a little bit down. Yes. Okay, so this is our parallel line. So this is a construction. Let's make a note of it. So point number 2 is construct. Okay, construct a line parallel to side AD. This is important. Parallel to side AD and passing through point B. Okay, and passing through point B. Okay, so if you look at this figure now, we have two triangles ABE and BED which lie between two parallel lines. Okay, and they have equal bases AE and ED, which means area of this triangle will be equal to area of this triangle. So I'm going to just revisit this proof which says this thing, and let's remove this. Yes, this was a theorem which we saw before. Let's read it. So two triangles on the same base, okay, or equal bases. This is important. Same base or equal base, doesn't matter. So this is the equal base for these two triangles, and between the same parallels, okay, this line parallel and this line parallel to each other, are equal in area. So these two triangles are equal in area from this theorem. So I'm just going to write it here. Yes, so let that be our point number 3. Thus, area of triangle ABE, okay, is equal to area of triangle BED. Okay, so in just to use a highlighter, okay. So this triangle ABE, area of this triangle ABE is equal to area of triangle BED. That is what we have proven. And this triangle is already equal to this triangle area, and area of this triangle is also equal to this triangle, which means area of all these four triangles are equal to each other. Okay, so thus let's come here because we don't have space, and in fact let me just cover this because now this is not needed, and I will use this space to write. Okay, so let's zoom in. Okay, so thus thus we have area of triangle ABE, okay, equal to area of triangle BED, okay, which is equal to area of triangle EDC, okay, which is equal to area of triangle AEC. Okay, so all these four triangles inside this triangle, all these four triangles in the triangles have equal areas to each other. Okay, so now it's just matter of observations. So let that be equal to x. Okay, and therefore so x plus x plus x plus x will be equal to area of triangle ABC. Okay, sorry, area of triangle ABC, because triangle ABC, because this whole triangle ABC is made up of these four inner triangles, and therefore now let's come down. Therefore 4x will be equal to area of triangle ABC, and therefore x will be equal to 1/4 the area of triangle ABC. Okay, but what is x? This thing, x is equal to all these four values, areas of all these four values. Now what we want is this area of BED should be equal to 1/4 the area of ABC. So if you notice the right hand side of the equation that we want to show, it already exists here. Okay, 1/4 of area of triangle ABC. Left hand side says area of BED. Yes, so x is equal to area of BED. So we can just substitute that value and say that is area of triangle BED, because that is the value of x, is equal to 1/4 the area of triangle ABC. And thus the proof of question number 2 is completed. Question number 2 is quite dependent, okay, quite linked with question number 1. So first you have to understand how question number 1 was solved, and only then go to question number 2. That's it.